Alright guys, so I promised to work on the last few multiple choice problems, at least for 43, 45, and 50 for the first half of the multiple choice portion of our fall final. Alright, so a lot of you guys might remember this jar, or maybe if you don't remember this jar, you remember this jar, okay? So in class, Ashley was able to find the one bead, the one black bead in here out of a million or almost a million yellow beads, okay? So if you look here, I don't know if it's going to mirror it, but I'll read it to you guys. There are 999,999 yellow beads, okay? That's pretty high parts per million. There's 1 part per million of the black particles, okay? In this one, we see that, one, it's mostly blue, okay? The blue ones are composed of, they're like considered the background. The yellow ones this time are going to be 100,000 parts per million, and there's still only 1 black bead. There's also a bunch of other colors, red and green as well, okay? So why are we talking about these beads? Well, because in class, we were talking about something called parts per million and parts per billion. So parts per million, that's what that M stands for, and parts per billion. Again, this is for question number 43 on your multiple choice portion, okay? So 1 part per million means 1 out of 1 followed by 6 zeros, which is the same thing as 1 over 1 times 10 to the 6. This is 1 part per million. 1 part per billion is 1 followed by 9 zeros, which is 1 times 10 to the 9, since it's 9 zeros, okay? And again, this is 1 part, 1 part per billion. All right, so that's kind of the basics, understanding what ppm and ppb stand for, okay? So if we look over here, 1 milligram of toxin per liter of water is the equivalent of 1 part per million. Oops, I think I skipped back and forth in my PowerPoint. All right, so if this one is equal to 1 milligram per liter, what is the 1 part per billion going to equal? All right, so 1 milligram per liter, how could we put that? All right, so 1 milligram, remember milli means 1 out of 1,000. So that means milligram means that there has to be 1,000 grams or milligrams to equal 1 gram. All right, that's what the milli means. Now I've come to the realization that you guys don't understand what micro means, okay? So 1 microgram means 1 times, or 1 over 1 million instead of just 1,000. Okay, do you guys see the difference there? There's a whole set of 3 zeros that are in micro that aren't in millos. So micro is a lot smaller than milli. Okay, for example, you could have a millimeter, but then a micrometer would be 1/1000th of that millimeter. It's pretty small. So if we look over here, we see that the difference between 1 part per million and 1 part per billion, how many zeros are there difference of between 1 times 10 to the 6th and 1 times 10 to the 9th? Again, 3 zeros, just like how 1 milli, okay, so that's 1 over 1,000, and 1 micro, which is 1 over a million, is also different by 3 zeros, all right? So the correct answer choice for this one, if you're looking onto your test, is that 1 part per billion is going to equal 1 microgram per liter, okay? 1 microgram per liter. Now, if you guys need to refresh yourself on the metric system, which you definitely need to do if you're going to be in science, okay? Even if you're going to be in a science class and you don't want to do science as a career, Metric system makes a lot more sense. During our road trip to California, this is going to be off on a tangent, but during our road trip to California, we were talking about land and real estate, and we were like, how much is an acre? What exactly is an acre? And it came out to be some like random number, like 5,000 feet. And we're like, where did they get that random number? And it turned out to be that's the amount of land that an ox could plow in a day. And it didn't make any sense because like you could have a big ox, you could have a small ox, but that's just me giving the standard system a hard time. The metric system instead makes a lot more sense because everything kind of follows these multiples of 10. It's a base 10 system, okay? So it's going to be by 1,000, it's going to be by 100, it's going to be by a million, but everything's multiples of 10 when you're going from one subunit to another subunit. All right, so again, our final answer, 1 part per billion, is the same thing as saying 1 microgram per liter. All right, let's see. So that's for problem number 43. Let's go ahead, and I'm going to try to squeeze in problem number 45 and 50 all within this video. So it's going to be a long 15-minute video. So 45, how much energy is saved in kilowatt hours? Excuse me. Okay. How much energy is saved in kilowatt hours if a family that uses 100-watt light bulbs for an hour a day for 30 days switches to a 60-watt light bulb instead? So again, this is problem number 45. So if you have 100 watts and you use them for 1 hour a day for 30 days, okay, how many watt hours is that going to take? And versus if you have a 60 watt, what is that going to be? And you're going to find the difference between the two, right? So let's see here. How can we start off this problem? 100 watts times 30 hours, basically, because it's 1 hour per day, would give us 3,000. And since we're multiplying, the units kind of combine together. 3,000 watt hours. Okay, 3,000 watt hours. Now, if we had a 60 watt light bulb, and again, there's still 30 days, okay, and we're only using it 1 hour for each of those days, what would that give us? That would give us 1,800 watt hours. Now let's take the difference between those. 3,000 watt hours versus 1,800 watt hours. Well, that simply gives us 1,200 watt hours. Now, I just told you guys to review the metric system. If we're dealing with thousands instead of thousandths, okay, there's a difference between thousands with just a D and thousandths with a DTH, right? We're not dealing with a fraction, we're dealing with something greater than that, okay? That's going to be kilowatts, all right? If we're talking about kilowatts, or it could be kilometers if we're talking about meters, right? So 1,200 watt hours, it should be a big W, excuse me, is the same thing as saying 1.2 kilowatt hours. Again, this was a question that was missed by a majority of you guys, and maybe even you guys that got it right, maybe you're just randomly guessing, okay? So 1,200 watt hours is the same thing as saying 1.2 kilowatt hours. All right. Again, I'm going to try to squeeze in number 50. If you want to pause here and rewind, redo number 43 and 45 until you feel comfortable with it, feel free to do so. This is YouTube, so you have that power, okay? And if you do that and you're still kind of confused, come to my tutorials and I'll help you out. All right, so question number 50. Okay, so this one isn't really a math problem, but I'll go ahead and do it here anyways. So it gave you a little graph. Hopefully you have your test out in front of you. And this was going to be atmospheric CO2 levels, and this is going to be the span of years, okay? And what happened in this graph is that it would do something funny like this, okay? In which the overall trend, let me switch colors for the overall trend. the overall trend was increasing, but there was these cyclical variations that were happening. And those cyclical variations was basically what you're looking for. What was the reason for those cyclical variations? Okay. Now, as you know, the Earth is tilted. The Earth is tilted. So when the northern hemisphere is tilted away from the sun, there's a lot less direct sunlight that's hitting the northern hemisphere. Everything tends to be spread out. Instead, in the southern hemisphere, it's getting a lot more direct sunlight. So here in the south, it's summer. And here in the north, it's going to be winter, just because of the tilt. That was the whole thing with the Harvard video, right, that I wanted to show you guys. But then we lost a little bit of time because we were talking about SpongeBob, and then we started talking about not Dora the Explorer, started talking about Dory and Nemo, right? So the reason I wanted to bring up the seasons is because when it's winter in the northern hemisphere, what you'll notice if you look at a map of the world is that the northern hemisphere has a lot more land, okay? So what's our northern hemisphere look like? Something like this. Now this is really, really rough sketch, so you guys do not need to make fun of my drawing. But this is something that looks like the world, in which the equator is kind of running through here, right? So the northern hemisphere has a lot more landmass. So since it has more landmass, that means it also has more plant life. And if it has more plant life, that means that it's the hemisphere that's doing most of the photosynthesis. Now, what does that have to do with the seasons? Well, what happens in the northern hemisphere when we have winter and we have fall? Okay, you'll notice that even if you look outside of these windows at Davis High School, you see that the leaves right now, it's January, are falling off. There's trees that don't have any leaves. So if they don't have any leaves, would they be able to do this photosynthesis? No, they are not. So what happens is carbon dioxide levels tend to increase when there's winter in the northern hemisphere. Because remember, the reaction for photosynthesis is you're taking carbon dioxide as one of your products. And you're also taking a lot of other stuff. You're taking light energy, so I'm going to put E for energy, EL for energy. And you're converting this into glucose plus oxygen plus water. Oops, excuse me, water should be a reactant. Okay, so you're taking carbon dioxide, water, and light energy, and you're converting it into glucose and oxygen. So when it's summer and spring in the northern hemisphere, what's happening is it's taking more of that carbon dioxide. So it tends to drop during the northern hemisphere summers. But during northern hemisphere winters, you don't have those leaves to carry out photosynthesis. That's why CO2 levels start to rise. Okay? I don't know how well I explained that. If you want to look it up on another YouTube video, you can do so. And I mean, it's just, it takes a little bit of thinking. There's a lot of connecting the dots here. There's the graph, there's the whole seasonal thing, the tilt of the Earth. There's the idea that there's more landmass in the northern hemisphere, therefore it conducts more photosynthesis, and you actually have to know the reaction of photosynthesis. So I can understand why number 50 was a tough question, but I think you guys should have still gotten it anyways. Okay? So again, Friday we're going to cover the rest of the multiple choice portions as well as introduce the free response portion. All right, see you guys Friday.